Hello, welcome back to our intermediate algebra course. And today we're going to talk about section 7.3, simplifying radical expressions. Today's challenge, since we're talking about radicals, has to do with a square root. If the square root of x equals 1234, what is going to be the square root of 4x? And I don't know, this sounds, it looks kind of confusing and complicated. It's kind of funny because we have the number 1, 2, 3, 4 in a sequence. Maybe this is kind of a hint on how to solve it. Or maybe we can wait until the end of this section and we will have some help from the topics we'll cover. Okay, write down your guess and we will check it later. Simplifying radical expressions, let's use the product rule for radicals to begin with. Let's say we have the square n root of a and n root of b. If you multiply the n root of a times n root of b, there is a property, the product rule, that says you can write this under the same root, nth root of a times b. And this is going to be helpful to simplify radical expressions. Sometimes you have to join together like this. Sometimes you have to split. Let's have a look at some examples, because this is just a definition and doesn't look like very clear. But when you see the examples, I think you can understand. The square root of 3 times the square root of 5. Since we have a square root and a square root, both have the same index. It's an invisible index, right? The index of the square root is 2. But you don't need to represent. Okay. They both have the same index. You can write under the same square root 3 times 5. And that's equals to a square root of 15. It's a simpler way of writing down a square root of 3 times square root of 5. Nice. Cube root of 4 times cube root of 2. Look, both are index 3. So we can write under the same cube root 4 times 2. In this case, 4 times 2 is 8. And that's good because a cube root of 8 is equals to 2. See, you can simplify and find the answer as a whole number. Okay, square root of 2 over a times the square root of b over 3. Write down everything under the same square root, and it is going to look a bit simpler to b over 3a. That's it. We cannot simplify this any further. We can use the quotient rule also to simplify radicals. It's kind of very similar to the product rule. If you have n root of a over n root of b, you can write this quotient under the same n root a over b. And the same thing, sometimes you want to join together under the same root. Sometimes you want to split. We will see case by case. Look, we have all under the same square root. We can split, we can break down. Square root of 5 over square root of 16. This is helpful because we know what is the square root of 16, right? We don't know square root of 5, so keep square root of 5 over square root of 16, 4. That's the answer. That's a simpler version of this expression. The square root of 40 over 81. Same thing, break down, and we have square root of 40 over square root of 81. Helpful. Square root of 81? 9, yes. And square root of 40. Now we will go back to the product rule. We can break it down because 40 is 4 times 10. Look, we can break as the multiplication of a number that is a perfect square and another number. Then split into two square roots, square root of 4 times the square root of 10. And we know the square root of 4. 2 square root of 10 over 9. Again, this is a simpler version of this original expression, square root of 40 over 81. Now the examples, we use this quotient rule to simplify. Assume that all variables represent positive real numbers. Okay, we're going to work with variables here. Look, we have some variables, and you don't need to worry about the sign. The question is saying these are positive real numbers. Okay, letter A. Let's use the quotient rule, break down. That's going to be equals to cube root of 27 over cube root of 64. Okay? But cube root of 27, you can use a calculator if you're not sure. But 3 times 3 times 3 is 27. So cube root of 27 is 3. 64, cube root of 64. If you don't know, use the calculator. 4 times 4, 16 times 4, 64. 3 over 4. That's the final answer. Look, much simpler version of the original, right? Now letter B. Let's write down, let's solve in a different color. Fifth root of 7 over 32 x to the power of 5. Okay, now we're going to break down. This is equals to fifth root of 7 over fifth root of 32 x 5. We don't know the fifth root of 7, so keep it like that on the numerator. But on the denominator, I think we can simplify a bit more. Fifth root of 7 over, break down, because fifth root of 32 times fifth root of x to the power of 5. And look at each one separately. We know the fifth root of 32. 2 times 2, 4 times 2, 8 times 2, 16 times 2 again, 32, yes. So 2, and this we can simplify. Fifth root with the power of 5, so we have x. Fifth root 7 on the numerator. Okay, much simpler version of the original expression. Simplifying radicals. Now we have a sequence of examples. We will apply the rules. We will apply some techniques to simplify those radicals. And very important, if the final answer for any question is a radical, you have to write down the answer in the simplest version. It's kind of like rational expressions. Remember, fractions, you have to always simplify the fraction. The same thing, you have to simplify the radical expression. Here, we done this one, right? We can break down as the square root of 4 times the square root of 10. That's simpler. And we know the square root of 4 is 2. Square root of 10, we don't know. Next, square root of 300. Always try to find two numbers that multiplied equals 300, but one of the numbers needs to be a perfect square. Like 100 is a perfect square, times 3. square root of 100 times the square root of 3, and we know square root of 100 is 10 square root of 3. Okay. And here on the bottom we have square root of 15. Can we simplify square root of 15? Look, 15 is 3 times 5. We don't have any perfect square here to simplify. That means no, there's no simplification, just keep it like the square root of 15 is the simplest form already. More simplifications. Try is cube root of 16. 16 is not a perfect cube, is a perfect square, but we can break down as the multiplication of a perfect cube times another number. Look, 8 times 2. 8 is a perfect cube. Cube root of 8 times cube root of 2. And 8 is 2 times 2 times 2. Cube root of 2. 2 times cube root of 2. Another one, another example. Cube root of 3 over 64. Okay, let's break down. Cube root of 3. There's no simplification here on the numerator. We're going to keep it like that. And cube root of 64. This is a cube, it's a 3. And no, that's good, 64. I think we can find the cube root of 64, right? Cube root of 3 over 4 times 4, 16 times 4, 64. That's the answer. All right, next examples. Simplify each radical. Assume that all variables expressions represent positive numbers, so you don't need to worry about the sign. We have a variable here, x to the power 7, and this is square root. Remember, the index is 2. We can break down, because we can write this as x square root. And we don't need to represent this index. We know it's 2, right? X2 times x2 times x2 times x. Remember that the power is invisible, is 1, right? So we have an invisible 1 here. Is that right? Because if you multiply x squared times x squared times x squared times x, we have to add the exponents, 2 plus 2 plus 2 plus 1, 7, right? And now we can simplify, because we know that the square root of x squared is x, and we don't know the square root of x, so we will keep. That is going to be equals. I'm working here step by step, so you understand what I'm doing, okay? But when you get confidence, you can do this in one step. This is x cubed, square root of x. That's the final answer. Try to understand all these steps, but after you're confident, you can jump from this to the final answer, because you're going to realize you're going to have quicker methods. We will see a quicker method later to jump from this expression straight to the final answer. All right, next one is square root of 20. Let's break down square root of 20 over square root of x to the power 16. And again, on the top numerator, we can break as a perfect square, 4, and another number 5. On the bottom, we can break down into several perfect squares, x squared times x squared times x squared times how many times we're going to have here? Let's repeat this. 1, 2, 3, 4, 5, 6, 7, 8. 8 times, right? So we have 16. Correct? This is equals square root of 4 is 2. Square root of 5. And we will have again, the square root of x squared equals x, right? Because we cancel. We have 8 x's multiplied x to the power of 8. And maybe you're noticing how to jump, how to calculate this from this expression is straight to the final answer if you look at the power and if you look at the index. In this case it's invisible too. Let's check on the next example how we do it. Okay, simplify each radical, assume that all variable expressions are positive numbers. Breaking down, we have cube root of 54 and we have cube root of x to the power 6 and we have cube root of y to the power of 8. I think the best way of working quickly, let's do one by one. Cube root of 54, we need to find two numbers. One number is a perfect cube. The multiplied is 54. I think 27 times 2. Yeah. And look at this power. We have this power 6. We have the index 3. Can we divide 6 by 3? If you divide 6 by 3, you have what? 6 divided by 3 is 2. And the simplification here is x squared. This is how you will work out. Divide the power by the index. A problem. We don't have, when we divide 8 by 3, it's not a whole number. It's going to be like a decimal, right? If you divide 8 by 3, you have a whole number and a remainder. You're going to have a remainder. Look, the way of simplifying this is multiplied, y. Okay, 8 divided by 3, we cannot divide, but we can divide 6 by 3, right? 6 divided by 3 is 2, and we have a remainder 2. This remainder that you're not able to divide by the index, we will keep inside the root. Oops, is a 2. The remainder is 2, and the index is 3. Look if it makes sense, and we still can simplify because we want to find the cube root of 27. Cube root of 27, 3. Cube root of 2, sorry. Times x squared times y squared times cube root of y squared. All right, we are almost there. There's one final step that we can work out to make this a bit nicer and simpler. If you have a multiplication, you can join together under the same root, as long as the index is the same. The index is 3. Let's keep the 3, let's keep the x squared, let's keep the y squared, and we're going to join together these two factors that are in separate roots. Let's join under the same cube root of 2y squared. Nice, that's the simplest expression. Okay, this example here, we needed to work a little bit more, right? Several steps. I suggest you review it later because it's a very good example where we apply lots of properties, important properties that will allow us to simplify radical expressions. Use the quotient rule to divide. And we have a square root of 20 over a square root of 5. Write down under the same square root, 20 over 5. 20 divided by 5 is 4. And a square root of 4 is 2. I think to simplify will be better to join together this quotient under the same cube root. So keep the 7, and this is going to be the cube root of 48 y to the power of 4 over 2y. Nice. Now we have everything under the same cube root. Let's look inside the root and check if we can simplify something, right? 48, can we divide 48 by 2? Yes, 48 divided by 2 is 24. So simplify here. And y4 divided by y. Maybe you remember the property of exponents. If you have a division and this is an invisible 1, the power, you're going to subtract 4 minus 1. And the power here is going to be a 3. Nice, we managed to cancel out the denominator, and then we have 7 cube root of 24 times y to the power of 3. We still can simplify more, because 7 cube root of 24 we can write as 8 times 3. And we can break down everything into separate cube roots, right? So let me write down here. Cube root of 3 and cube root of y cubed. Nice. And let's use this. Now we have 7 cube root of 8. 2 cube root of 3. No, we don't know, so keep it. And cube root of y3, y. Let's just rearrange a little bit so it make it nicer. 14 y cube root of 3. You can write like this, or you can write like that. 14 cube root of 3 y. Just make sure you don't make a mistake of thinking that this y is inside the cube root. Anyways, I like better this way so we don't make this mistake. We don't make the mistake of thinking that the y is inside the root. Okay, using the distance and midpoint formulas. This is just an application since we're talking about radicals. It seems interesting to show a very nice application using the Pythagorean theorem. We can derive a formula for finding the distance between 2 points using Pythagorean theorem. In this example, we have to find the distance between the points 5 and 8 and 2 and 2. That means 5 is the x-coordinates, 8 is the y-coordinate. Let's say this is point number 1. 2 is the x coordinate, 2 is the y coordinate, and let's say this is point number 2. Let's identify those points in the graph, 2 and 2. Let's start point 1, sorry, point 1, 5 and 8, okay, and point 2, 2 and 2. Nice. So we have, this is point 1, this is point number 2. Perfect. Now we want to actually calculate the distance between those 2 points. Let me mark the distance as a blue line. No, it's supposed to be a blue line. Okay, a blue line, nice. And let's write down distance D. If you notice, we can build here a rectangle, triangle. That's a right triangle. And the legs of the triangle, you can identify. This is one of the legs. This is another leg. And the length of the leg is going to be, in this case here, 8 minus 2. And here 5 minus 2, right? So applying Pythagorean theorem, do you remember Pythagorean theorem? C squared equals A squared plus B squared. Let's call, instead of C, we will call distance. Distance squared equals A. Let's say A is this. Value here, 5 minus 2, and B, let's say this is B. B is 8 minus 2. Apply the square root on both sides, and then you have distance equals square root of 5 minus 2 square plus 8 minus 2 square. Distance equals square root 3 square plus 8 minus 2, 6 square. And distance equals square root of 9 plus 6 squared, 36. That's square root of 45. Okay, we can just draw the graph and come to the conclusion that it's possible to apply, to use the Pythagorean theorem, or let me give you another way, another option, right? And another option is to apply a formula. The formula will be G equals square root of x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. If you just plug in, you will have the same results. So square root of x minus 2. Let's say this is 2, this is 1, plus y is 8 minus 2 squared. And you have the same result, square root of 45. And remember, you have to simplify because 45 is 9 times 5, 3 square root of 5. That's the final answer. But what we are looking here is at the formula. Okay. One interesting thing, you can use this as 1, this as 2 as well. and if you plug into the formula, doesn't matter. At the end, you're going to have the same result. The distance will be the same 3 square root of 5, no matter which point is point number 1 and which point is point number 2. Okay, so that's the formula that you can apply. The midpoint is just because we're talking midpoint formula, it doesn't have anything to do with radicals. Since we're talking here about the distance, there's another thing we can also find is the midpoint. But basically, the coordinates of the midpoint is another formula. It's going to be, let's call midpoint equals the coordinate x of the midpoint, and those are the coordinates. It's going to be x1 plus x2 over 2, and the coordinate y of the midpoint, y1 plus y2 over 2. And if we look at the previous example, a quick sketch here, then we have a distance from this point to that point, and you also are able to find the coordinates of the midpoint, which is this exact point, halfway between point number 1, let's say this is number 1, and point number 2. So that's another formula that might be useful. Find the midpoint of the line segment that joins points. Now let's work with -5 and 8, -2 and 2. Let's say, again, doesn't matter. You can say this is point number 1, this is point number 2. The midpoint will be the x coordinates, x1 plus x2 over 2, and the y coordinates, y1 plus y2 over 2. The coordinates of the midpoint are -5 plus -2, -7 over 2. You can keep as a fraction. And 8 plus 2, 10, divided by 2, 5. Okay. That's the end of section 7.3. Finally, let's find the answer to our challenge. Try to solve if square root of x equals 1234 or 1234. What is the square root of 4x? Well, if you think about using the product rule for radicals, yes, you are right. We can break down, right? This multiplication, square root of 4 times x, you can break down as the square root of 4 times square root of x. Since we know square root of x is 1, 2, 3, 4, and we know that square root of 4 is 2, this is 2 times 1, 2, 3, 4, and the answer will be 8, 6, 4, 2, 2468. 2468 will be the right answer. Thank you for watching. Don't forget, answer the questions on MyLab Math about this section. And I hope to see you soon on the next meeting.